We begin this algebra class with understanding how to use the rectangular coordinate system. So in this lesson, we're going to learn how to plot points as ordered pairs, how to look at a graph and break down where there are specific ordered pairs within that graph, and just in general, how to use the axes properly. So we're going to learn how to construct a rectangular coordinate system. We're going to learn to plot the pairs and determine the coordinates of the point, and then how to graph paired data. So the Gateway Arch in St. Louis is a big architectural arch that just kind of looks like this. It's shown here if we wanted to graph it on a coordinate plane. Basically, the coordinate plane of the Cartesian system are these two axes that meet, and the y-axis or up and down axis is labeled with numbers there, as well as the axis or left and right axis. Here it's telling us that 1 unit equals 100 feet. So if we want to count up, we can see that 1, 2, 3, 4, 5, 6, a little above. And at its highest, this arch in St. Louis is about 600, maybe 620 feet. Rectangular coordinate systems formed by two perpendicular number lines, the y-axis that goes up and down, and the x-axis that goes left and right. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. On the x-axis, the positive direction goes to the right, or on our screen, it's going to head that way. On the y-axis, the positive direction is upward, that way. The scale on each axis should fit the data. For example, the axis on the graph, the arch, tell us that it's 100 feet each. For the most part in this class, you can just assume it's 1 unit that it represents if you're not told otherwise. Here, when it tells us the positive direction is to the right, that means the negative direction on the x-axis is to the left. When the positive direction in the y is up, that means the negative direction is down. The point where the axes intersect is called the origin. This origin is going to be an important word in your homework. It's going to ask where to begin. When you begin graphing, you always begin at the origin. So that point is called 0, 0 because you've moved 0 left and right. You've moved 0 up and down. From the origin, I can divide using the axis into 4 quadrants. I'm not really that concerned with you understanding the quadrants for this class, but if you do go on and take Algebra 2, Pre-Calculus, Calculus, the quadrants will become more important. They go 1, 2, 3, 4 counterclockwise around. The axes are really the dividing lines for quadrants, so they're not considered to be in any specific quadrant. Each point on a coordinate plane can be identified by an ordered pair of real numbers x and y. An ordered pair is a parentheses, a number that represents how many to move left and right, a comma, and then a number to represent how many to move up and down. So they're always represented as x, comma, y. How to move horizontally, how to move up and down. The numbers in the pair are called the coordinates of the point that they map to. Some examples of ordered pairs are 3, -4, -1, 3/2, and 0, 2.5. For the most part, you guys are going to be working with whole numbers here, so don't worry too much about how to graph the 0.5s and such, but basically, if I was graphing 2.5, I'd want to be halfway between 2 and 3. If I was graphing 3/2, I'd want to be halfway between 1 and 2. In general, we just look at the first number, which tells us to move left or right, so this says that the x-coordinate is 3. But we would move 3 to the right to get to the x-coordinate. Second number here, -4, is the y-coordinate. What that really tells us is we'd have to move down 4 to get to that y-coordinate. So the process of locating a point on the coordinate plane is called graphing or plotting the point. The figure to the right, we use 2 blue arrows to show how to graph the point with coordinates of 3, -4. So where we start is here at the origin. To graph the point 3, -4, we start with the x-coordinate, which tells us to go 1, 2, 3 to the right. Once we're there, we move on to the y-coordinate, which tells us to go down 1, 2, 3, 4. So this point is the point 3, -4. 3 in the x direction, -4 in the y. If we switch those two coordinates and now tried to find the point negative 4, 3, we'd start by going 1, 2, 3, 4 to the left, and then going up 1, 2, 3. So again, if the first number is positive, it means to the right. If the first number is negative, it means to the left. If the second number is positive, it means up. If the second number is negative, it means down. So on the previous screen, it showed us how to get to these 2 points, 3, negative 4, and negative 4, 3. The way that you're going to be asked these questions in the homework is as fill in the blanks. So it's going to say something like we start at the answer is always going to be origin. You always start at the origin or 0, 0. Then it's going to say move 4 units and ask you to fill in the blank whether it's left or right. Because in this case, it was at negative 4, I would fill in left as the direction that we were moving. Then move, again, it'll be a fill in the blank, 3 units and draw a dot. Because this is a positive 3 as the second coordinate, I'd fill in that blank as move up 3 units and draw a dot. In the figure to the right, we see that the points negative 4, 0, 0, 0, and 2, 0 all lie on the x-axis. In fact, anytime that you get a point where the second coordinate is 0, meaning you haven't gone up or down any, it has to lie here on the x-axis. Similarly, if the first coordinate is 0, that means you haven't moved left or right any, which means the point has to lie on the y-axis. Plot each point, then state the quadrant in which it lies or the axis on which it lies. So I'm going to go somewhat quickly through these, but basically in the next few slides it's going to tell you how to get to each of these points. We'll start at the origin and move the corresponding number of units left or right based on the x coordinates. Then we'll move up or down based on the y coordinates. So for the first one, the x coordinate is negative 2, so we're going to start at the origin and move 2 units to the left. Since the y coordinate 3 is positive, we're then going to go from where we move 2 units to the left and move up 3 units. So we start here at the origin, we move 1, 2 to the left, and 1, 2, 3 up. There's our ordered pair, negative 2, 3, where we would plot it on the coordinate plane. To plot the point negative 1, negative 3 halves, we begin at the origin. So again, we start here at the origin. Then we move 1 unit to the left, there's 1 unit to the left, and 3 halves down, or negative 1 and 1 half. To get to that point, negative 1, negative 3 halves. To graph 0, 2.5, we begin at the origin. Because 0 is the x-coordinate, we don't have to move it all left or right. And then we move up 2.5. So we move up 2, and then halfway between the 2 and the 3. So here's that movement. We don't move it all left or right because it's 0 as the first coordinate. Then we move up 2.5 to get to the coordinate 0, 2.5. So that point lies on the axis. Something only lies on the axis if one of the coordinates are 0. If it's a 0 as the first, the x-coordinate, then it lies on the y-axis. If it's a 0 as the second, the y-coordinate, then it lies on the x-axis. To graph 4, 2, we begin at the origin. We move 4 units to the right. 1, 2, 3, 4. Then we move 2 units up. 1, 2. You're going to get questions like this in the homework that show you a picture and ask you to identify points based on this picture. So the 4 points that I'm going to identify are this one at the top of the circle. To get to that point, I would go starting at the origin, right 2, so it would have a positive 2 as the first coordinate, down 2, so it would have a negative 2 as the second coordinate. The next point I'm going to get to is here. To get there, I start at the origin, I go right 5, so the first coordinate would be 5. Then I go down 5, so the second coordinate would be negative 5. To get to the next point on the circle, I go right 2 and down 8. So the coordinates would be positive 2, negative 8 for that point. The final point that I'm going to identify is this point here. To get there, I start at the origin, I go left 1 and down 5. So the coordinates would be -1, -5. Really, I chose these 4 points because they happen directly where 2 lines cross, so I get 2 whole numbers out of these. The ones that you're asked in homework, they'll give you one of the 2 coordinates and you just have to identify the other coordinate. So there are the answers: 2, -2, 5, -5, 2, -8, and -1, 5, which correspond to the 4 points that we found on the circle. This graphing paired data is really just showing you how it's going to apply in your science classes. The ones that I'm going to ask you to do for homework, it's going to be more straightforward. Here's a line, here's one coordinate, find the other coordinate. But it is important for you to understand that this does apply to graphs, this does apply to higher order concepts that you'll be seeing in other classes here. So, when we look at quantities that are related, we might look at something like the time it takes to cook a turkey, which depends on the weight of the turkey. So when we talk about depends on, if you tell me what the weight of the turkey is, using that information, I can then tell you how long it should cook. Dependent and independent variables are important to identify. Basically, the x variable is the one you get to choose. It's independent. In this case, the x variable is how much the turkey weighs. Based on that, we use a formula to say that the dependent variable, or the y coordinate, must be this. So, we can use graphs to visualize these relationships, where if we know the input, we can get back the output. If we know what we want x to be, we could find out what y would be using some formula. So this is showing us that the time it takes water in the tub in order to get that water to a certain level, this is how many minutes have elapsed. So suppose we know the number of gallons of water that are in the tub at several time intervals, we can list that information in a table. 0 minutes in, there was no water there. After 1 minute, there was 8 gallons of water. After 3 minutes, 24 gallons. And after 4 minutes, there were 32 gallons. We can take this information, input, output, and put them in as ordered pairs. 0, 0, 1, 8, 3, 24, 4, 32. So we've taken a real life situation and we found a way to represent it as something that can be graphed. The information in the table can be used to construct a graph that shows the relationship between the amount of water in the tub and the time the water has been running. Since the amount of water depends on the time, so we're going to leave the faucet open. Depending upon how long that faucet is open, that's going to tell us how much water went in. We choose how long to leave it open. As a result, we get a set amount of water. Independent what we choose, how long the spout stays open. Dependent, which must happen based on the spout staying open, how many gallons end up in the tub. So here we take the ordered pairs and we graph them. 0, 0, where we start, is down here in the corner. Then when we've moved 1 in the x direction, or 1 minute of letting the water run, we've now gone up 8 and have 8 gallons in our tub. If we go 3 minutes of letting the water run, we would have 24 gallons in our tub. If we go 4 minutes, we would have 32 gallons. So you can see that this information has been used in order to create a line graph. I could now take some number of minutes that I didn't record, for instance 2 minutes, and say the line looks like it hits 16 gallons at 2 minutes. So if I was asked what that ordered pair was, I could find that ordered pair 216.